Today we are discussing energy efficient buildings. Call them green energy buildings, call them zero energy buildings. The concept is same. The concept and what is the concept? The concept of energy efficiency is to change the overall conventional methods and condemn the high energy footprint practices. Simply, a penny earned is penny saved, and by using energy efficient buildings, we save a lot of money that goes in the running of a house, appliances that go into the house, and the money that goes into the bills. Energy efficient house cut down so many of that thing. It should have been the energy efficient approach should have been our very first preference, rather than what we are doing is a rectification. We are having so many schemes, so many policies that go in to aid the concept of energy efficiency. Rather, it should have been our very first approach towards the construction, towards execution of the projects. Energy efficiency for any structure is the practice, of reducing the detrimental impacts with which the planning, execution, and operation and maintenance is done. It is the practice of creating the structure which are environmentally responsible and resource efficient throughout the building's life cycle. Energy efficiency, is not a fancy term. It's not something which is in fashion now, and that's why we are adopting it. It's been there. It's an age old concept. It's a way of construction of buildings, or residential, non-residential, which now we have put together with proper planning, execution methods, which are scientific approach, or analysis or simulations which we do in the software to know the best possible results. Energy efficient building are constructed today, which actually is a time tested practical, and it's an intuitive approach to create environmentally sound buildings. They combine age old wisdom, traditional and modern building science, technology, and material application. These structures are energy efficient, conserve resources, create healthier indoor environments, and offer durable and beautiful spaces. Now, taking the second criteria of energy efficient building is the design part. Design part is very important part, because this is why you tend to make a minuscule change in overall construction process of an energy efficient building, yet you uphold larger and enormous results. Following things are taken care of while we discuss the design part. First thing is low energy material and technology, water efficiency and recycle and reuse, reclaimed materials. Then we have low energy and affordable building materials and technology, prevention of soil erosion by providing proper turfing and landscape areas. And then we have rainwater harvesting, preparation of landscape to reduce heat, which we also known as urban heat island effect, reduction in usage of potable water. For that reason, we have smart faucets, taps, which we will take later in our slides, in water efficiency. Then we have recycling of waste water. So many things are taken care of as the design, as far as the design of the energy efficient home is considered, because the end product needs to be very efficient, needs to be environmentally responsible, needs to prove the cut down on the cost which goes into the construction. Third thing which we here understand are the objectives. What is the objective of an energy efficient home or the green building home? We understand there are very frontliner cities or states, like for example metropolitan cities, who have continuous 24-hour supply of electricity, and that is only possible when the second liner cities, for example, which are non-metropolitan, which cities or some third liner villages, bear the burnt of that, because power cuts, water shortage, they face those things so as to ensure that the social standards are maintained in metropolitan cities. So the objective of the energy efficient home is always been to promote energy efficient building design, to minimize the energy used, to come up with the design of a house or a building, which could be residential as well as non-residential, such that the building is be able to manage its energy use on its own, depending upon the climate of the region, depending upon the solar radiation availability. It's able to manage its energy usage on its own, and is and eventually becomes environmentally efficient and responsible towards the inhabitants as well as towards the external environment. Now, understanding the active and passive solar, active solar and passive solar. So there are two things which goes into running of an efficient energy home, because both the things work hand in hand. They run parallel in an energy efficient home. So one thing which we have is active solar. Active solar is simply when we use or make install some modem or module which converts the sun's energy into usable form of energy. For example, we may use it in the form of electricity, heat, cooling, etc. Similarly, the another type of the solar technology which we incorporate in an energy efficient home is passive solar. Passive solar is a very minuscule concept in overall construction or the design or the execution of the overall project. But the result, the output which we get from incorporating such a minuscule concept is enormous, because the household or a residential or a non-residential house behaves smartly. We tend to come up with a design which is smart in itself just by incorporating small change in its design, which we will take in the very next slide as we will discuss the passive solar of the residential or non-residential houses. So, before we learn about the solar passive design, we first understand the sun path chart, the trajectory of the sun or the behavior of the sun with respect to our planet. So, the we are very much aware about the aphelion and the perihelion position of the Earth in its orbit with respect to the sun. So we are very much aware about the winter solstice and the summer solstice. That we have shorter days in winter than in the summer, and longer nights in winter than in the summer also. So this thing is totally governed by the position of the planet in its orbit, and we are very much aware about the fact that we don't have constant duration of day and night hours throughout the year, and that goes on changing. We have shorter days, or we can, or let me put it this way, that shortest day in winter and longest day in summer, which we often refer as December 21 or June 21, or winter solstice and summer solstice, respectively. So, what does sun path chart give us an idea about? It gives us an idea about the amount of solar hours you are able to have in a particular day of the year. So, this thing is to be understood from the sun path chart. Second thing, one needs to understand the solar window, irrespective of the vegetative cover. If you are in an urban area, you have shades, you have adjacent buildings that may interfere in the solar window you will have. So for that reason, one may understand the amount of solar gain one has available. And also we need to understand that whatever, when we were discussing the aim or the objective of the solar passive design or overall the energy efficient houses, so that there's an energy deficit, there's an energy deficiency in this planet. There was and there will be, because of the population explosion, because of our higher living standards. And for that reason, we need to understand that needs to be covered by something, that needs to be coped up by something, and that coping mechanism or that coping device is sun. So our dependability or our usage of the solar rays or solar radiations into our useful form in our daily lives, or to come up with a design that could be smart enough to use the solar radiations on daily basis, is actually a tie between sun and the design which we come up with. Here, the sun path chart also helps us to understand the amount of solar hours that are available in a bay area for any day in a year. Also, it helps us to understand that there are 2 days for which we have 12-hour duration day and night availability, which we often refer as equinox. There are 2 days that could be March 21, that is vernal equinox, and September 21, known as autumnal equinox. And why we are so peculiar about knowing these equinox days? Because these are the days when we manually determine the orientation of the south, because we are here in northern region. So south is our solar gain direction, through along which we are able to gain our solar radiations. So south is our vital direction. So for that reason we are able to determine the orientation manually. Also, it helps us to understand the amount of solar hours which we are able to have. In addition to this, one more thing which I like to put it here is that a sun path chart also helps to understand the position of the sun. For example, we can see that the winter sun is at a relatively lower level than that of the summer sun, which also helps us to optimize the sunshade of a building on all the 4 directions of the building. And it also leads us to step ahead in terms of economizing the structure. Now, here in this slide, we will be discussing solar passive design parameters, and we'll take all the design principles one by one. First thing which we'll have is shape. We are here in a temperate zone, and in this temperate region, the shape of a home is very important and plays a very important role in designing the solar passive design. To determine a home's thermal performance, because that is what one of the important criterias we'll be talking here, is that we offer a roughly rectangular shape. Ideally it has to be cubical, but here, as we talk about the temperate zone, so we want our homes to be roughly rectangular. It should be elongated along the larger dimension should be along east west direction rather than along the north south direction. So because that is how we will be able to ensure to have better thermal efficiency of any structure, of a residential or a non-residential structure. By this thermal efficiency, we mean finished floor area of the house to that of the sum of its all exterior surfaces, which gives us the floor area to the surface area ratio. And for any greenhouse structure, for any residential home structure, there should be higher F to S ratio, which will ensure higher efficiency of the building. Second parameter which we have in this design principle is orientation. Orientation is very important for any solar passive house, because as I said, these are the minuscule changes which we make in the design of the solar passive house, but the outcome of this minuscule change is enormous. It helps us a home to behave very smartly with respect to the climate on outside, and helps to totally resonate with that climate on inside. So the ability of the home to properly utilize the solar heat gain in winter and mediate the sun in summer depends a great deal on how the home is placed on site, especially the window directions. This includes the proper positioning of the home on ground. So that this positioning is done either by magnetic compass, or we simply go and find the true south manually. So by visiting the Bay Area or the site area, we go on determining on the day of the vernal equinox or on the autumnal equinox, we determine the direction, or we'll simply go with the magnetic compass, go with the magnetic direction of the north, and will easily point out towards the south. Or simply on the day of equinox, we will go and find the direction of the south. And on this, based on this orientation or the direction determined of the south direction, we go and orient our house. And every direction has a role to play, and every direction along which we extend the dimensions of a structure in the Bay Area, every direction has a role to play. For example, on north side, this is our coolest, or for the most of the days of the year and the maximum number of the days of the year, this area remains shaded. So what we ensure along the north direction is that it is properly buffered. We have very less apertures on this direction, or if we have apertures, they are properly insulated. And similarly, we have east, where we understand the sun normally and usually is below the horizon, and we have a pleasant morning sun there, so we use the east area for porch or the breakfast corner. Or we have we usually ensure that along the east side, we have morning sun, so that could be used as a proper patio, loggia, or sun deck also. So then along west side, which we have evening sun, and evening sun is often in summer is a very blazing hot, and we ensure that we have properly covered the area, or we have very less aperture size on that area, and we have even reduced the dimension along that area. So we ensure that to cover the east by properly providing trees, trellises, sunshades, or carports also. So south is our main heat gainer. Along that side, we ensure that we have large apertures. We ensure that we have properly smart and high performance windows provided along the south side, which could actually trap heat inside, or in winter, and take away the heat in summer, because as and when we will optimize the sunshade for it. Third criteria being layout. Layout is very important criteria of the design principle of solar passive house. By properly arranging the internal arrangement of the rooms, one can easily manage the heat or the cooling that goes into a proper functioning of the house. For example, we for any structure, we will put sting or the living area along the south side for a person who lives in the northern hemisphere or above the equator. So for that reason, we will put the sitting or the living area along the south direction, and we will tend to have bathrooms along the west direction. For example, we have kitchens which have natural tendency to increase the heat because cooking goes on there, and for an ethnic country like India, where we have lots of gatherings, so kitchen is very important place to be. So for that reason, we tend to put kitchen along north direction or on along northeast direction. So breakfast corners often goes along east direction because of the morning sun, which normally is below horizon. So a proper arrangement of the internal structure of any structure helps us to properly manage the internal heat. By putting the living areas or the sitting areas along the south direction, you don't need much amount of heat to we don't need much amount of energy to heat the area, as in winter the south facade will be able to trap the winter sun in, and will be able to heat the area on its own. So these things, by taking criteria of such things, helps us to devise a plan or a layout of a smarter building, which conventionally we don't use, or which we conventionally don't incorporate in our design. By incorporating such minuscule things, we can come up with the results that could really we can count for. Fourth criteria of this design principle, which we will be discussing, is the aperture. Aperture is something which we refer as windows, and in any solar passive design, south facing windows are very important. They are actually home solar collectors, as windows are not just only solar collectors, they are at the same time they are one of ones with low insulative values, unlike walls. So they are hands down energy losers of the four compass direction. So the south facing windows in any conventional home is about 3% of the overall floor area. But in any solar passive design, we have raised this percentage to 7 to 12%. And for any energy efficient home, we do not stick to just conventional windows. We have raised we are in requirement of high performance windows, smarter windows. So two criteria that need to be looked at. First is the low U value and low E value. U value is thermal transmittance, and it should act in this building envelope on either direction. It should be able to seal the atmosphere inside the building, and at the same time should not be allow the transmittance of the external temperature to inside of the building. So this thing is to be taken care of in any high performance window. Second thing which we will be discussing here is low E value. Low E value is actually the solar reflectance, the ability of a window to reflect the solar infrared radiations. So with this infrared radiations, what happens is that we are able to take away the solar radiations in which normally may enter the building premises. So for that reason, we have buildings which have low E value, and for winter we can go on having open our windows and allow the solar gain, because we already have optimized the sunshade that will ensure that the sun in winter enters into the areas facing south. So for that reason, we have taken the care of the proper ventilation mechanism, or windows which will be in favor of having the infrared radiation during winter, but at the same time repelling them in summer. Also, we have visible transmittance. Visible transmittance value ranges from 0 to 1. For for any energy efficient building, the visible transmittance value, we want light and not infrared radiation, so our window should be such to ensure a good amount of lighting and at the same time repelling the infrared radiations. So this is the understanding, this is the concept of high performance windows that goes into the solar passive design of residential or non-residential homes. Now we have roof overhangs. Roof overhangs, awnings, sunshades, overhangs, call them whatever you want. The idea in of roof overhangs in any solar passive design is to understand the position of the sun. Winter sun is to be going to be lower than that of the summer sun, and you will have an angle you get depending upon the position of the sun throughout the year, especially on the solstice days. So for that reason, you optimize the design of the sunshade, understanding the nature of the sun on the outside in the sky with respect to the amount of sunlight or infrared radiations or the visible light transmittance you need inside the building. So numerous analyses are carried out in any software that helps to support and design the solar passive house. So we understand the position of the sun in the sky, and based on that an angle is devised. We go on and optimize the sunshade, the offset of the sunshade, the amount of the overhang that is to be provided over the window, and all along the and on all the sides of the directions. For example, this analysis is to be carried for north, south, east, west, all four directions. How optimizing sunshade helps us to economize our building, because by optimizing the sunshade we are able to understand a concept that you may or you may not need same overhang along all the sides of the building. Yes, you can use a sunshade to take to protect the windows from splashes of rain, but that is one thing. But another thing which we are here trying to understand is the amount of solar radiation you need inside the building and what you need to keep away from the building. So by optimizing the solar radiation, by optimizing the sunshade, we are able to maximize or minimize, and a range of amount of a range is a range of amount of solar intensity is to be understand, which we need inside the building. Before we go and understand the simulations, which I said that we optimize sunshade, we check for the layout. We have sunroom in the solar passive design, which is which is the governor of the heating and cooling inside the building. We have ventilations, we have sunshades, we have awnings, we have thermal mass. So many analysis goes into the design of a solar passive design. But here, what are the two key factors that goes into the software which helps us to guide, which acts as a guide in the simulation process? The two things are, first, the coordinates of the Bay Area, and second thing is the climate data. First thing is the coordinate. Your Bay Area's position on the globe or on the planet is very important, because that is how you understand the position of the sun, your longest day, your shortest day, your hottest day, your your highest rainfall day. And this is how you understand the climate. This is how, when you put the climate thing in this figure, that the role of the climate is very important in all the simulation mechanism, because we are cooling, we are regulating the cooling and heating inside the building based on the climate, or the sun availability, or the cloud cover, or the snowfall, or the rain that is available to you in that very particular area. That is the climate of the area. So in order to carry out the simulations, we go on and collect the data of the climate for that very particular bay area. So there's a very macro classification that has been done. So for the macro classification, what data you are in need of is sunshine data, rainfall, solar intensity, radiation, temperature, humidity, cloud cover, or even sometimes snowfall data. This data is not in the same form as you need in the software. So the crude data needs to be properly scrutinized, it needs to be properly reframed, so as to be put in the software, which is so as to put in the software in a usable form. Analysis. So various analysis and simulations help us to understand, to arrive at a figure which give us believable shape to the believable shape and figure to the hypothesis which we have been making so far. So the first analysis which we will be discussing will be shading analysis. So for in shading analysis, for a design of house or a structure, we analyze the display of shadows hourly, daily, giving an idea about the awning size. These displays of the shadows which we are about to analyze are known as butterfly diagrams. They help us to design the dimensions of the shading devices, which is optimized automatically. The data on which this settles is hourly shade data, day wise shade data, or sun's position in the sky, based on which we come up with the optimized dimension of the sunshade along every direction. North has its different awning design, so is east, west, and south. So, second analysis which we will be discussing will be space load analysis. A building system can work on grid as well as off grid and passively regulate the energy on its own. But to check the load a building is able to carry, or the load of the building structure, gives us an idea about the sustainability or the efficiency of that very structure. So monthly space load graphs are to be generated, they are to be jotted down to understand the load on appliances for heating and cooling of the system or the space inside the premises, while making an account for passive solar and active solar should be also incorporated into the building structure. This is the very analysis where we help, where we actually slide in the active solar part into the building structure, because we understand a building can be designed passively, but incorporation of the active solar can altogether enhance its working as a smart structure. Third analysis here we will be discussing is about thermal loss and gain analysis. The solar gain may occur in various methods. We have three types of gains actually. So we have direct gain, indirect gain, and ventilation gain. Direct gain we know as the process of allowing solar radiations in a building during the heating season, and as in the sunroom, etc., windows on the south, the apertures facing the sun, and amount of solar gain which we have from that portion, the amount of heat which we are been able to generate in the sunroom, and then it goes on diverted along all the living area. So this is the direct gain which we get from the windows, the apertures. Now we have the indirect heat gain, solar radiations which are absorbed by a massive assembly such as trombe wall without direct admittance to the sun. So here is the this whole of the thing rests on admittance. For example, we are talking about trombe wall. What is a trombe wall? It is a massive equator facing wall that is pointed that's painted, actually that it's pointed towards the south direction, but it's painted with some dark color, or dark covering, in order to absorb the thermal energy from incident sunlight, and covered with a glass on outside with an insulation air with the insulation, that is the air gap has been provided between the wall and the glass surface. So this trombe wall allows the transmittance, and not only the transmittance is ensured, that here the high E wall is ensured, and the transmittance is also ensured that the proper emittances takes place. That is, whatever heat has been absorbed by the structure, by the component of the structure, that is properly emitted into the area or into the space, so as to ensure the proper heating of the system. So this is some of the heats and gains which are under heat gains and losses which we understand by thermal loss and gain analysis. This also gives us an idea about the thermal mass which we use in the space. For example, we as we discussed earlier, that the living and the sitting spaces should be placed on the south direction of the structure in for the northern hemisphere constructions. So for that reason, when we place the sitting and living areas along south direction, what we understand is that we ensure that the solar gain is there in winter. So we should be able to trap that energy also. So that trapping of energy occurs by proper amount of thermal mass, and we have to provide flow of such nature that it should be able to trap the infrared radiations, and not only trap, it should be able to properly emit it to the space, and emit in proper proportions, so as to heat the space, heat the area, such that the load on the appliances is reduced, and the energy bills are reduced. Now, our very last analysis which we will be discussing here is solar infiltration analysis. This analysis actually done to understand the proper functioning, proper working of a sunroom. Sunroom is a governor into a solar passive system, solar passive design of a structure. So this sunroom, what it does is this helps to increase the temperature of the area by trapping the solar radiations in winter, and at the same time by ensuring proper amount of ventilation for of the sunroom, we are able to have better ventilation activity into the system or in the space. Also, we are able to cover the skylights, we are able to prevent the entry of the solar radiations into the space or premises in the summer as well. So this in this solar infiltration analysis, we ensure and we make a proper check on the amount of solar radiations that comes into the sunroom. So proper analysis are been done by which we understand that how much amount of solar radiations come into the system, which are responsible for heating the system, and as well as how much amount of solar radiation we are able to repel from the system by providing proper amount of cover over the skylights, by providing proper ventilation, by covering the facades. So with this reason, we are able to actually understand the working and the functioning of the sunroom in any solar passive design. So now we have is that ECBC, Energy Conservation Building Code. Energy Conservation Building Code is formed as a result of Energy Conservation Building Act in 2001. So the purpose of this code is actually to provide the proper guidelines for any design, to provide a proper track to follow for any consumer, for any dealer, for any one who wants to invest in the solar passive design, who wants to encourage such type of construction. So guidelines have been ensured, and these are not just guidelines for design, aperture, layout, or orientation, but these are far more. They form the far more wider pedestal than one can think of. You get idea about the compliance documents and forms, the suitability forms documents, what you need to put into the system, what you need not to put in the system, what is necessary, what is mandatory, and what is not required, or what is least required. So you get an idea about you actually draw a boundary line for any passive solar design. Also, you need to one needs to get an idea about the simulation requirements and calculations, what calculations you need for it, how much amount of aperture side is required, how much amount of floor area is required, what goes into the floor area, what type of material is best suited for the floor area, what goes best in the windows, what goes best in the roof, what goes best in the walls. So all these things are properly guidelines have been put into this ACPC code. Also, they also give us the idea about the softwares that helps us to carry out the simulations, to know the software is one tool which helps you to understand the results, to get the results results of any structure and how much efficient results you will be able to have before before the time, before its actual construction and execution. So it also gives us an understanding of the electrical and renewable energy system. For example, in energy conservation building code, it not only gives you an idea about the electrical system that goes into the any energy efficient design, like for example air cooling, cooler, crushers, grid dependency, input from the grid, and also give at the same time it gives us the idea about the scope of active solar which you can put into the system. For example, photovoltaic lighting system, interior and as well as exterior. We have rooftop technologies, we have concentrated solar technologies for non-residential houses, for example like ashrams, hotels, messes. We have solar water heating system and so many other active solar devices which the code itself gives the proper scope to be incorporated in any energy efficient home. At the same time, it gives us comfort system and controls, that is how much amount of comfort we can put into this any energy efficient home, such that we may not feel that we have deprived any energy efficient home of any luxury or any comfort than any conventional structure which we normally construct. Also, it gives us an idea criteria about the building envelope. It takes care about the visible light transmittance. It gives us about idea about the U value. It gives us about the idea about the E value. It gives us an idea about the R factor, and so many things are incorporated in this building envelope system that every component of the building should be under these and these norms. It gives the value, it gives the idea, it gives the proper range with which we need to select the material for any energy efficient structure. Also, it gives us a macro classification of the climate. Since energy conservation building code is actually climate dependent, if for Uttarakhand it will be different, for Jammu and Kashmir it will be different, for Punjab it will be different, for southern India it will be different, for so will be for the eastern and the western India. So energy conservation building code actually gives you the macro classification that has been carried out by the meteorological departments and so many other organizations, that helps us to understand the different climate, and based on that climate what simulations are best suited for any structure. It also gives us the schedule, that is the material characteristics, which is one of the very important factor. Not only the coordinate and the climate data goes into the software, but very important third parameter, that is the climate, that is the material characteristic. For example, if you have shingle, or if you have wood, or if you have brick, or if you have hollow bricks, so there are U value, E value, the transmittance value, things parameters vary from any material to material. So for that reason you need to have those values available so as to be feed into the software, for based on which it may carry the analysis and simulations. So that material characteristics has been properly devised into the code, which helps us to understand the proper simulations, which helps us to understand the better working of the software, and obviously arriving at the most appropriate and most accurate results. Also, it gives us an idea about the occupancy schedule. It is a very maybe to some people it may be very unknown term, what is occupancy schedule, but it is one of the very important parameters based on which the passive solar design is actually it actually is one of the important parameters in the passive solar design. So occupancy schedule is something, the amount of hours you spend in any space, based on which you are able to understand the heating and cooling that goes into the system, that may be required by the space. So for example, you have a living area, you have sitting area. For that reason you have maximum, for example, we may schedule that 11 to 12 hours goes into that this type of area. Similarly, for bathroom you may put like 4 to 5 hours into the bathroom. Like for example, if there are 5 to 6 members in a house, they approximately spend 4 to 5 hours on like summation. The cumulative hours will be 4 to 5 hours per day in the bathroom. So is for the kitchen, so is for the roof, so is for the attic, and based on that we are able to understand how much amount of load we are going to put on the appliances, and or how much amount of load goes into heating and cooling of the system. So also it gives us, as I said earlier, it gives a scope of involvement of renewable energy. So energy conservation building code involves this one parameter, that is renewable energy generation zone, which gives us idea about that ECBC building or ECBC plus building or super ECBC building. This is the classification of the buildings that is being jotted down by the energy conservation building code, and based on this classification it gives us the idea about that how much amount of percentage of renewable energy generation zone is required into that very structure. Embodied energy is something which we will attribute here to the material efficiency. This is very important because we in any energy efficient design or building design or zero energy building design, one always aims to cut down on the carbon footprint. So all the materials that goes into any structure really helps us to understand that the cradle to grave journey of any element of that very house or any structure should be minimum, if not zero. If we are not able to pull that energy consumption to zero, but it should be as minimum as possible. For example, the manufacturing of the brick, like right from the extraction to process to transportation to manufacturing to then again transportation to the site or the construction site, and then the execution or the installation, then maintenance and operation, and then finally the disintegration of the material back into the nature. So this all journey should be involve should this entire journey of any element of any energy efficient building structure should involve zero energy or at least minimum energy. So we understand that extraction of raw materials, transportation of material, manufacturing or processing of materials, usage and at the same time disposal of the material, this entire journey should ensure that least amount of carbon footprints are involved here. We also need to understand other parameters that any energy efficient building should and necessarily and mandatory should incorporate. First is water efficiency. Water efficiency is something where we need to understand that water is to be not only used, it should be efficiently used, it should be recycled, it should be reused. We should have a parameter of wastewater management, like we have sullage, we have sewage. Okay, sewage you just put into the STPs, or you can treat it at source. For hotels, for hospitals, for restaurants, it's mandatory that source treatment should be there, but before letting it into the STP. But also we need to properly manage our sullage. For example, sullage water can be partly treated and used for in kitchen gardens, or on and or after being partly treated, it should be used in faucets or flushing things. So at the same time, water efficiency also includes smart faucets. We have smart taps, sensor based taps, which help us to control the amount of water that goes into the sinks or into the flushes or into the wash basins, etc. Also, we control the amount of water usage by providing low head. We control the potable water availability. By this, we are able to control the use of the water and not able to waste the water. Second thing we have is urban heat island effect. Urban heat island effect is actually a microclimatic change. This microclimatic change is something which we understand by putting too much amount of high carbon footprint materials in any area, which altogether results in raising the temperature of that area. For example, we have an area where we have vegetative cover, we have trees, we have stream also, and we have, say, artificial lake also. But for that reason, that helps us to lower down the temperature of that area. One eventually feels that surrounding very soothing, very comfortable, and very less distracting. On the other hand, if we normally city centers, we have city centers which we have where we have more concrete, where we have more concrete structures, where we have enormously amount of high-rise building structures and less vegetative cover, which altogether results in higher temperatures, and this change occurs in very same region, in very same area, this microclimatic change has been felt. So this microclimatic change is to be taken care of, because what happens is we actually are intending to lower down the hardscapes. We do not need much amount of hardscapes, so we ensure that if where we need hardscapes, we should always have a scope of vegetative cover. We should always have a scope of turfing. We should always have a scope of trees in any structure. So urban heat island effect is something which needs to be taken care of in an energy efficient home, not only kitchen gardens, but instead of going for concrete pavements, instead of going for hard pavements, we always can have vegetative covered pavements, or we have turfed pavements, or we can have simply pervious pavements, which helps us to recharge the groundwater whenever the rainfall comes. So this is another way of helping and supporting the nature, because as we are in case in any area we have tube wells where we have water that is taken from the groundwater, where we have groundwater dependability, and at the same time we should be able to ensure that we are ensuring that there's a groundwater recharge. Another parameter which we'll be discussing here is material efficiency and use of reclaimed materials. Material efficiency, which we already discussed, that cradle to grave journey of any component of any building structure should involve minimum amount of carbon emissions, and this can be also included or incorporated in any conventional building structure in its construction also. You just have to make just a petty change and you are there one step in the track of this energy efficiency. So now we will be discussing here is the use of reclaimed material, because that is what is important. We have to set reclamation trends, because what it does is it helps to cut down over on the dependency over the forest, cut down over the dependency of the natural resources. We've been depleting we've been feeding these resources to us for over a long period of time, till this age of depletion now. No, so for this reason, what we have structures, structures get erected, they get dismantled at the same time. The construction business goes on. So at the same time, when you go for construction of any structure, you can always look for a reclaimed materials like wood, for timber, for steel. Steel has high scrap value. It can always be reused in any structure. Now we will be discussing landscaping and xeriscaping. It's not always necessary when you go for construction you have to exclude the nature from the construction. You can always include. There are so many beautiful examples where the construction and the nature have been included, and such an inclusive environment has been brought up that it actually touches your heart when you go for such type of construction. So landscaping is something when we go for we do not need to go for the construction of a concrete jungle. We can always have concrete structures. It is sometimes a need. We cannot totally deny our dependability on the concrete, but where we need concrete structures, we should not totally neglect our landscaping. So xeriscapes are something, they're dry plants. They can survive on very less water. They are very low maintenance plants. Here we will be discussing about Griha rating or energy rating. We have uh, there are organizations who acknowledge and consider the efforts made in support of this cause of energy efficiency of zero energy buildings. So Griha is an organization which not only supports energy in efficient construction, but also rates, in terms of monetary support it provides, in technological support it provides, guidelines it provides. It also helps you to rate a building. By the energy star rating, you are able to you're able to go a step ahead in this direction. Not it only boosts your morale, but it encourages you to go steps far ahead in this direction. So Griha assesses a building out of 34 criteria, awards points on the scale of 100. So many criteria goes into it. If you come up with an innovative technique, innovative design, or innovative method of execution of any energy efficient house, it will give you a star for that. It there's a pointing for that, there's a rating for that. Similarly, so many aspects, the type of windows you put into the building, the structure you erect, any type of material that is reclaimed, and what use you have made it in the very new structure. So you get rate based on these things. The rating also may involve and occupancy sensors, water faucet sensors, tap sensors, and lighting sensors. So these things, what they do is they help us to make any building very efficient, and very smart structures have been made up out of these, by taking care of such criterias. And based on these criterias, this griha organization rates a building, and the reviewing of mandatory points and checking for compliance. The project is rejected if mandatory criteria are not complied by. So this griha is something, and so many organizations also do it. Like for example, we have lead, they do it. They do the energy star rating for any structure, and by energy star structure, one can also, the such organizations also support you monetarily, and also boosts your morale. You get certification, how much amount of carbon emission mitigation you have been able to put into your project. You get star for that also. That you get point for that, and basically that it later turns into a star rating. So this was our presentation on this energy efficient building, and we hope you liked it. We hope it was worth listening. We hope it added to your knowledge. Thank you so much for listening.